So on to another problem. Going on to integrals now. So calculate the integral of 4x to the power of 6 minus 2x to the power of 3 plus 7x minus 4 dx. Okay. So first off, to go over what is even the point of an integral. The point of integral is to have a way to represent. Let's say we have like some weird line like this. Let's say it ends here, just to make it obvious. We want to be able to, given like the equation for this, find the area here. And this is useful because it allows us to. There's a lot of real life problems where we need to calculate not just like, for example, if we have the speed of a car, we can use the integral to calculate, or I guess like an equation for the speed of a car. And I'll write that down. Speed of a car. And we have the equation for this. We want to find, though, not maybe the speed at a certain time, but the distance traveled over a certain period of time if speed changes. I don't know if that might have confused you guys a bit more, but basically think of a car moving at 60 miles per hour, then it goes at 50, then 40, then 50, then 80. You can see how it becomes kind of confusing when it's changing constantly and you want to just find distance. That's where integrals come in. We could think of this equation as the equation for the speed of a car at any given time x, and we can use this to come up with an equation for the distance rather than the speed. So finding integrals is not really that hard. It's just about, formulas really just add 1 to the exponent and divide this by the coefficient. And you do that for each term. So in this case, it's pretty easy. It'll just be, well, we have 4x to the power of 6. So 6 plus 1 is 7. 4 divided by 7, 4x to... Oh, I should write this out. This is going to be annoying. It'll just be 4x to the 7 divided by 7 for the first term, because we add 1 to 6 and so forth. So that's our first term, minus, add 1 to the 3, we get 2x to the power of 4, and we divide by 4, plus 7x squared divided by 2, because we take x to the power of 1 plus 1, 2 by 2. And then here, this is where it gets a bit tricky. Think of this as 4x to the power of 0, because we know when we take x to the power of 0, we get 1. 1 times 4 is just 4. So it'll just be 4x to the 1 divided by 1. And finally here, we could just simplify these fractions. And I'll write it out. 4x to the 7 divided by 7 minus x to the power of 4 divided by 2 plus 7x squared divided by 2 minus 4x. And that is our, well, we should add a c. Always add the c, because there's always some constant. This may have tripped everyone up, but what this constant means in like the car example is, well, we know how fast the car was traveling, or like the speed, but we don't know like at that time where the car started from, like the offset, or like where the car started from. Or I guess like the car may, like, we have a car, two cars moving at 5 miles per hour. Car A moving at 5 miles per hour could have started at 30 miles from the house. Car B, same speed, could have started 60 miles from the house. And that's where C comes in, because C is a constant representing either 30 or 60. And that's why this is important. Just with the, basically in other words, with only the speed of the car, you don't know where the car initially started. So we need the C constant at the end when we calculate the integral equation. That's pretty much it. May have been a bit fast, but any questions, I can upload a subsequent video, follow-up video, I mean, to explain it. But yeah, have a good one.